All right, so let's do chapter 3.2, where we left out the day. We left out at chapter section 3.2, whereby we were about to discuss about fragmentations. Okay, so inside the paging section, okay, paging, what we have is we have virtual memory, we have physical memory, and we have the backing store inside this page here. Okay, so let's go into let's go into fragmentation. Okay, so what is fragmentation, or what is internal fragmentation to be exact? Internal fragmentation is whereby you have an empty space in between your programs here, in between your programs. So this is the partition inside the memory, and each of these partition size are all the same. All right, and if the operating system were to put any programs inside here, the programs will fit according to the size of the partition. But in certain situations, the program might be smaller than the partition. For example, partition 2 here, program B is smaller than the given partition, and the same goes with program C, which is smaller than the partition. So those empty partitions are what is known as internal fragmentation. It's an empty space within the given program. Okay, and this empty space cannot be given to another program. Okay, it remains for program C only. Let's say there's another program coming in, program D. Program D cannot sit inside here, neither it can sit inside here. It can only be fitted inside this free partition space. Okay. Next, we have a non-contiguous allocation. This is a picture of your RAM. Always remember, at the top of the memory or RAM, which is the would be the operating system. This will always be there. When you on your PC, until you shut down your PC, the top part of the RAM size would be your operating system, and each of these locations are your processors. In a non-contiguous allocation, the processors can be divided into several partitions. Okay, several partitions, and it can be not side by side. Non-contiguous means the process is inside the memory, but is not side by side. As you can see in this example, process 1 and process 1 here are the same, but they are not side by side, meaning to say one is at the top, one is in the middle here. And process 2 is also here. It's not side by side. If it's side by side, then it's known as a contiguous allocation. Contiguous allocation. Okay. So user processes, which are these processes, are then held at high memory. Why is it called high memory? It's because of the address size increases. Okay. The address size here is always at a very low memory, because the address starts with 0. Okay, the address starts with 0 and it increases downward here. So that's why it says that the lower part of the memory has the operating system, and as the memory goes higher, then it will have all the programs here. Okay, or sorry, processes here. All right. In a non-contiguous allocation, okay, a non-contiguous allocation, this one here, non-contiguous, the processes are divided into several parts. Okay, the processes are divided into several parts. Why is it so? Because when the operating system runs a particular process, it cannot hold all the process files because the RAM size is very, very small. Okay, so the processes have to be divided into several pages or several segments. Okay, so only when there is a necessary for the operating system to use a particular page, and then the CPU will call for that particular page. Okay, so whatever necessary files which are to be executed by the operating system, all those files will sit inside the RAM, physical memory. Okay, but as the physical memory size is very, very small, only certain files will sit inside the physical memory. The remaining file might be inside the hard disk. So if the CPU requires these files, it will request from the for the file, and this file will be located in the physical memory or in the hard disk as well. Okay, so that is what it means by paging. Okay, all right. We can also have segmentation, meaning segmentation is something like this over here. This green item here, which is called the logical address, is inside the CPU. If the CPU requires a specific file from segment 0, then the CPU will come up with a logic address to be referred to inside the segment table. Where is the segment table? The segment table is inside the RAM. So it will refer to this segment table and to get the specific location of the file inside the physical memory, or if it's not inside the physical memory, it's inside the hard disk. Example, segment 0 over here. So it will check where is segment 0. Segment 0 is base 500. What does base 500 mean? 500 means is the starting address of the particular segment. And what does 600 mean? 600 means the size of that particular segment. So this size is where inside this is where the particular file of the segmentation of segment 0 is. Okay, let's see segment 4. If the CPU requires segment 4, it will come up with a logical address of segment 4. So segment 4 is inside base 3800, which is here. And the size is 400, meaning the width or the size of the segment is 400. Meaning to say, whatever files that is needed by the CPU is within this segment 4. This is segmentation. On the other hand, in paging, where the CPU comes up with the same logical address, it will first refer to page table. Here is page table, here is segment table. The page table keeps the frame address. Where is the frames? The frames are inside the physical memory. All right. So page table has a frame number, and frame number is where the physical memory is. And what is D? D is the offset value. That means the specific location of the file inside the physical memory. Okay, so this is how paging and segmentation looks like. All right. So paging, a memory management scheme that permits the physical address space to be of a process to be non-contiguous. Okay, bukannya bersebelahan. Physical memory RAM is broken into fixed size blocks known as frames. Logical memory CPU is also broken into blocks of the same size called pages. Okay, let's see how it looks like. It basically looks like this. Okay, I'll come to that later. Okay. All right. So paging requires a page table to map the logical and the physical. Okay. So what it does is, so remember this formula later on, we are going to study that. Okay. So logical address, which is generated by the CPU, dia akan keluarkan two numbers, which is the page number P and D offset value. Alright. And the physical address akan ada dua benda, which is the frame number and the offset value. So where do you get the frame number? The frame number comes from something which is called the page table. The page table keeps the frame numbers of a given page number. So dia akan check macam ni. Okay, let's go to this example. So these are the pages here, and these are the physical memory here, and this is the page table. If CPU requires a file from page 0, the first step is it will check inside the page table. Where is page 0? So page 0 is inside frame number 1. So it will refer to frame number 1 inside the physical address. Okay. So physical address, page number 1 is inside frame number 1. Page 0, frame number 1. Page 1, frame number 4. Page 2, frame number 3 is here. And page 3, frame number 7. Okay. Let's look at this example. One whole block here is what is known as page 0. Okay. So page 0 is inside frame number 5. 0, 1, 2, 3, 4, 5. A, B, C, D is here. Page 3 is inside frame number 2. 0, 1, 2. Okay. MNOP. MNOP. Page 3 is inside frame 2. 0, 1, 2. MNO, MNOP. Okay, that is how you look at it. Okay, now let's try to do this example. Given physical memory size of 64. Okay, size dia 64. Physical memory itu apa? Physical memory is your RAM. Okay, okay, so kita dah dapat dah. Size dia ialah 64. Okay, 64. Page size dia ialah 8. And the page number is given in the center here. What is page size? Let's look here. Page size ialah size ni. This page size here. Meaning to say this is 64. Physical memory is 64. Page size ialah 8. Okay, physical memory 64 meaning dari atas ni sampai ke bawah size dia ialah 64. And page size dia ialah 8 bytes. Page size always equals to frame size. If you look at the formula, number of frames equals to memory size atau page size. Okay. All right. So how do we do this? Let us look at the example. Example here. Okay. Calculate the physical address for the logical address. 23. Okay, 23. So it wants you to find okay for each logical address 23. Okay, so this 23 is the logical address. So now we have to find what is the physical address. And what have we been given? We are given the physical address memory size. Okay, so how do we do it? So you first start drawing the physical address first. So as we know, the size of the physical address from top to bottom is 64. So it starts at address 0, it finishes at address 63. Because size dia ialah 64, but kiraan dalam OS always starts from 0. Okay. This picture which I'm drawing is now called physical memory. Okay. Each page size ialah 8. So di dalam physical memory dia ada frame. So frame size equals to 8. So 64 divided by 8, you get 8. So this is 0, frame 0, frame 1, frame 2, frame 3, frame 4, 5, 6, and 7. So this is frame 0, frame 1, frame 2, frame 3, 4, 5, 6, and 7. Okay. Now, You're given the logical address 23. So logical address 23, you're supposed to find physical address. Ni formula dia. So physical address equals to frame number. What is the frame number? Okay. What is the frame number for 23? 2 ialah page number and 3 is the offset value. Offset value solution, yeah. So 2 ialah page number. Okay. So page number 2 is inside frame number 3. Okay, frame number 3. Okay, 3. Multiply by frame size. Frame size equals to page size. So page dia ialah 8. Okay. Plus offset value. Offset value ialah 3. So the answer is 27. Okay, 27. One of this is 7. Okay, so the answer is the physical address for logical address 23 is 27. Okay, now try to do this question pula. The physical address for logical address 10, this one here. 10, what is the answer pula? What is the, this is the logical, and now you have to find the physical address. Okay. All right, I give you 2 minutes to do this. Okay, 2 minutes to do this. Let's see whether you can get this question.
24.
Okay, what is the answer for logical address 10? What's the physical address?
24.
24. Any other answer? How do you get 24?
Empat darab 8.
4 darab 8. Kenapa 4?
Eh,
4 darab 8 biasa saya belajar 32. Betul lah, 4 darab 8 tu betul. Tapi 4 kali 8 bukan 32 eh?
32.
3 kali CV pun susah. Okay, so did you get the answer 24? Yes, sorry, saya pula silap. 32, okay? Because 1 is page number 1, frame number 4. So 4 multiply by 3 plus by offset. Offset dia kosong tu je. So you get the physical address. Okay, so 4 times by 3 is 32. Okay, all right. So you can also do questions like question number 2 here. they want you to find out the logical address given the physical address. Okay, it is also possible if they give you the physical address and diorang terbalikkan, they want you to find the logical address. Pun boleh juga. So in this case, you are given the physical address 13 and 18. You are asked to find out the logical address pula. Okay, it is also possible. Nanti you can try this. Okay, next we go on into segmentation. Okay, segmentation. What is segmentation? Segmentation is a situation whereby the program is broken down into several segments. Okay, and each of these segments are kept inside the physical memory. When the CPU requires a particular file or code from each of the segment will be checked again with the segment table to locate the specific file. Example, in this example, let's say the CPU is looking for segment 3. Okay, so it will check inside the segment table. But before that, where is the segment table? Segment table is also inside the memory. Okay, so segment 3 is inside base 3200. Segment 3, 3200. 3200 is the base address. And the size of this is 1100. So 3200 campur dengan 1100, you get 4300. So inside segment 3, somewhere dalam ni is the required file by the CPU. Let's say the CPU requires segment 2. So segment 2 base dia ialah 4300. Okay, 4300 is here and the size is 400. So it's until 4700 and the required file for segment 2 is inside this particular location. That is how you do segmentation. Segmentation is very straightforward. Okay. Okay, so same examples here. We can do that, segmentation. Okay. All right. Okay, last but not least, for today, we are going to understand what is virtual memory. Okay. So if the question asks you, what is virtual memory? So virtual memory is a additional storage given to the RAM, and this additional storage comes from the hard disk. Okay, so there are situations where your RAM size, or what we say is your physical memory, is not enough to store the programs. So when this occurs, when there is not enough storage inside your RAM, or what we say as your physical memory, the operating system takes a part of the hard disk and converts it into a physical memory. Okay, and converts it into physical memory. So there are more programs or processors which can be inside your RAM. Okay, so if the files are not enough inside your RAM, the operating system automatically converts a small portion of the size inside the hard disk to become the physical memory and stores the programs inside. Why does it do this? Because any program that needs to be executed by the CPU needs to be inside the physical memory. However, physical memory storage is very low. So there are certain conditions, certain times that the physical memory is filled up. So that is why automatically the operating system takes a small portion of the virtual memory of the hard disk and converts it into a physical memory. So the section that is converted from hard disk to physical memory, it is what is known as virtual memory. Okay, so virtual memory. So you can read on your own what is virtual memory. Next, we are looking at page fault. Page fault is something to do with virtual memory in situations whereby the files are not stored inside the physical memory. Example, this is paging example. So if this is page 0 and it refers to page table to find out the frame, so it has a valid bit here. Valid bit maksud dia ialah file ini is inside the physical memory. If it's invalid, let's say I'm looking, the CPU is looking for page 1. So page 1 is not inside here, is invalid. So kalau dia invalid, maksud dia ialah that frame is not available inside the physical memory, tetapi frame itu berada dalam hard disk. So the operating system needs to go and get that particular file which is inside the hard disk and bring it and put it back inside the physical memory. Okay, so the valid invalid bit will indicate to the operating system if the file is inside the physical memory dalam RAM atau if the file is inside the hard disk. If it's valid, contohnya frame 5, okay, sorry, page number 5, okay, inside frame number 9, meaning to say, and it's valid, it shows that the frame is valid and this frame is inside the physical memory. If the frame is invalid, for example, page 7, invalid here, meaning it is not inside the physical memory and the page or the frame required might be inside your hard disk or what we say is the backing store. So that is what it means by page 4. So if the files are not, if the frames are not available in the physical memory, then automatically it goes to a fork and the operating system needs to go and get the particular frame which is located inside your hard disk and bring it back inside your physical memory. So that is what it means by page 4. All right, so that is all for today, and this is some steps in handling what I just told you just now, how to handle page 4. So you need to understand this as well. Okay, that's all for today. Okay, others I'm sure you can read it on your own. Others is very simple. It's just some basic explanation only. All right, do you have any questions? Okay, so what I want you to do today is you need to understand what is paging, how to calculate paging. That's very, very important. You can get it from, you should be able to get it from the notes, and you should be able to understand what is segmentation, okay, how does segmentation happen, and you should be able to understand or explain how does the operating system handle page fault. What is page fault? Page fault is a situation whereby the requested frame is not available inside the physical memory, but is available inside your backing store or what we say as the hard disk. So that is how you handle page fault. Okay. Do you have any questions for me today?
No, sir.
Okay. Thank you so much. Please sign your attendance and I will see you in the next class. Thank you so much once again. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you, sir.
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 Thank you, sir.